Hey guys, really happy to be here. Like, Tel Aviv is an amazing place. We just slept entire night yesterday on the beach, so it's been freaking awesome. If you haven't done that yet, you should try out. Anyway, today we are here to talk about building a media player with React Native. And I'd like to tell you and show you how you can empower your app with any feature, no matter if it's already available in React Native or not. But before we start, let me introduce myself. So I'm Mike, and that's probably how most of you guys recognize me. So yes, I'm that guy who posts these Twitter updates twice a month whenever a new React Native gets released. I'm also one of the React Native core contributors, as you can see, responsible for releasing React Native to NPM. But apart from that, my focus has been always on a better developer experience, especially when working with native modules. So that was one of the reasons I have made our NPM link with Alexei that made installing native modules as easy as any other NPM package. And if you have been following React Native development for a while, you probably have noticed that our NPM was merged into React Native Core so that you get these functionalities out of the box when you install or create a new app. But we have done all these things just to make the process of working with native code a breeze for you. And the question is why? Like, wasn't React Native the solution for writing mobile apps cross-platform without knowing anything about native code, just React and JavaScript? So let's take a look. Like, here's the list of all the React Native APIs as of now. There is some stuff to control alerts, action sheets, animations, vibrations, more or less 45 APIs. Is that all a mobile app can do for us? Like, here's, for instance, a list of some of the iOS APIs. And I'm just wondering if you guys know a rough number of all APIs exposed by Apple. Just try to tell me any number you can think of. Like 1,000, 100? 4,000. Yeah, more than 4,000. So it's like 110 times more than React Native has to offer. And that brings us to question whether it would make any sense to ship this stuff, like to wrap it. Well, the answer is it won't actually make any sense. And here's why. Like, what matters to us as developers is the stability. Like, if we are choosing React Native at our companies, what we are looking for is the way to build cross-platform apps. For Android, for iOS, for Windows, other platforms, with JavaScript, technologies we know. And so, if we think of React Native as an abstraction that's in between, inside our app, it has to be stable. Because imagine that you are a native developer. You created an app, you shipped it to the App Store, and you got exceptions. You made that app, so you go check out the stack trace, and you see, like, what's the exception, you know where's the issue, you know how to fix it. But if it's an exception coming from React Native, because the core is not stable, it's pretty hard to fix it. It's okay that you don't know how, like, breach code works, because you should focus on building apps. And so we have to make sure that the core itself is stable so that you guys can focus on writing better apps, not on, like, posting issues or trying to fix them. So what we have noticed is that if we make the core small, it will become more stable. And so that's why React Native ships with least amounts of components that are available and widely used by the community. And that makes this process better, and we are hoping to increase the maintenance and stability in the course of months. And that's the moment when native modules come into the business. Like, if React Native is small, there has to be a way to extend it, right? So native modules write native APIs and expose them to JavaScript. And if you'll take a look at the React Native core, you'll notice that essentially most of the code is based on top of that public API. So that all these 35 APIs that we have seen, they are based on this concept. So that means you can do pretty much anything, because if that was possible in React Native, it's also possible inside your code base. I won't be diving into much details about how breach works and how the async communication between JS and native works, because that's not the main point of our talk today. But let's just see how the JS native call looks like, just to stay updated if you guys haven't checked that out yet. So this is an image picker iOS module that's imported from React Native. and it has a method can use camera. So that method returns a boolean indicating whether camera is available on a given iOS device. And so React Native itself doesn't know this, like it's just a framework, right? And our JavaScript runs inside a VM. So we got some access to web-like APIs, but we don't know how to guess whether camera is available. So there has to be like a concept of something behind that allows us to get these informations out. And in fact, if we will check out the source code, we will see that there is the canUseCamera method that calls native API, in this case UA image picker controller, and asynchronously tells us whether the source of type camera is available on the iOS device. So essentially, making the process of writing native modules easier leads us to building better apps. Apps that can satisfy any use case our clients could ever think of. Stuff like card readers, barcode scanners, Siri integrations. If there is a native API for that, we can pretty much do it. So a few months ago, I was on a call with a client, and he said to me, let's build a media player. And I have to say, I wasn't really convinced that React Native was going to be a good choice that will do the work. Of course, our client wanted a cross-platform solution, so betting on React Native was like an obvious choice to target Android and iOS. But a few months ago, things like background music playback or other things were not even discussed. There was some work going on in terms of implementing web workers and other things, but no one actually tried that yet. So it was like checking what are the limitations of React Native itself. So it's been a huge research for us, and today I'd like to show you a kind of a pattern that you can follow to write pretty much any app with a native experience quite easily without being a native code master. But before we go into the code, let's kind of try to list down the business features that we will have to implement for our media player. So here's I would say, typical media player app. Unfortunately, no longer looking like this in iOS 10. It has tons of features hidden by the UI, so let's try to go screen by screen. The first is the player itself. As you can see, it has a progress bar, some buttons to control the playback, like play, stop, next, previous, repeat, shuffle, track options. And the track options are just things like play next, add to app next, download offline, a delete favorite, add to playlist. But it's not like, that's not everything. We also have some other requirements that we cannot see. These things are living like behind the app. We have to handle incoming calls. Like imagine you are listening to Spotify song and, I don't know, someone is calling. The song stops. It doesn't happen automatically. It was coded that way. And when you are making a media player, you have to remember about doing these things as well. Lock screen, Android widget, headphones, car audio, background playback, all these things are making the process of using a media player a very nice experience. So I think you probably agree with me that it's quite a lot. At first, we didn't even know where to start, like what could be the first feature that we will be doing. What we knew, though, was that these APIs on iOS and Android are different. So we felt that if we decide to go native way, we will have to handle these differences, features and limitations of these APIs separately, which will cause us plenty of bugs, plenty of issues, different teams, and we will basically want profit and benefit from React Native capabilities. So instead of focusing on, so we decided to focus on something that seemed to be the core of the media player, and that was the playback. Now the playback is really just a side effect, if you think about it. It's a side effect to state changes triggered by the user interface or other input devices. Just like when you trigger a Redux action and you expect an HTTP request to fire, and when this request resolves, you get a success or an error action dispatched again with some payload. Without an action, without an initial action being dispatched, the HTTP request would never fire. And this is true for the playback as well. Like, there has to be something that will make the playback start. So instead of focusing on how the speakers should play our music, we should think about the play queue and how we are going to perform mutations on it. Because PlayQ is something that will be managing our songs, that will be holding the state, will be telling the application what's the current song, what's the next song, if the shuffle mode is turned on or not, and other requirements that we will be building. Now, if you remember from the previous slides, when I was listing down the business features, we had verbs like add, remove, shuffle. And what data structure these verbs remind you of? Anyone? Almost. Array, queue, something like that. That was good. So the play queue is nothing more than just an array of songs queued for the playback. And we can assume that the play service, that side effect, will always fire whenever the state changes. And OK, that's fine. But we still have to find a way to perform mutations on it in order to make our app actually do something. And if we'll take a look at, if we think of an array and functional stuff, it turns out it's just a matter of functions that operate on state. It looks similar to Redux reducer, for example, in switch cases. For example, in order to add a track, you just have to concatenate an array of play queue songs with a new track. Or to stop playing, you just have to toggle is playing Boolean from true to false. And now, a great thing about this approach is that you can ensure cross-platform stability without even writing any native code, any player binding itself. Like, we haven't even talked about native part yet, but we already have something that is similar to a player in terms of functionality. And the unit tests are also trivial to write because this is just JavaScript. There is no native code. Like React Native as an environment is not even required for these tests to be run. So we already know that the play queue is somehow the state of our app, and the player service is what produces the side effects. But now, before we actually go ahead and implement the player service itself, we have to somehow integrate that with React so that the UI changes and the buttons can actually do something. And that is, for example, when we call a play next track, the artwork will change or the buttons will change. And so we did it with state. Just to be clear, it's fine to use Redux or any state manager. We decided to start small to see how the app will work, what will be our requirements. Turned out set state and a set of higher order components was just enough for this. So why we decided to do it that way? Like, since we wanted the player service to react to state changes, the lifecycle of a component felt very idiomatic to us. Like, there is component did update, we'll receive props. That is a very good opportunity for us to actually handle the changes. And so before we start handling these changes, we have to somehow plug it into the component tree. And so we start with wrapping our outermost component. If you have ever made, if you are making a React Native app, you just call app registry register component. And that's the component you are passing there. So this is your root component, the one that's responsible for the entire app. And now, if we'll take a look at the function, there is nothing actually tricky here. It's just a wrapper. It wraps the component with another component, passes all the props, nothing fancy. So now we can just add a state that we have discussed previously, or any other play-related informations like integer, holding an index of the current track that's been played. And now the last thing is to add some methods so that we can perform these mutations. We have already seen them. So the add track is nothing more than just setting state. Then we can just pass an object, like a public API, down to the component, and we are set. And that's the beauty of the declarative approach, because our UI became just a set of pure functions that only had to reflect what state was telling, without thinking about player, without thinking about whether when I call a callback, do I have to handle an error? No. All the pure components have to care about is just firing callbacks and rendering the song, artwork, or any other things. But if you haven't already noticed, there is one extra thing in the render method that we haven't talked about yet. It's the component called player. And that's the one that will be producing our side effects. So let's think for a second, like, what are the most important things that this component should be aware of? Like, it's a player, so naturally, track is playing should be the most crucial props that we have to pass in order to start small with some basic features, right? So the implementation is also very easy. It's just a clean component with some props with flow type. And it's not a pure function just because we want to use the lifecycle. So we will be using methods like component did mount, will mount to set up and clean up some stuff. For now, I'm just going to leave that empty because we'll see the usage later. But we can use component did update to actually do the heavy work for us. Because that's the place where we can handle the changes. As you can see, we have track did change and play did change booleans. If track did change is true, we have to handle the track change. If the play did change is true, we have to handle the play change. And so the track change is really simple, actually. As you can see, if there is no track after a change, we have to stop the player. If there is a track change and player is still playing, let's just change the track and keep playing. But if we are not playing at the track changed, we just want to update the UI and start buffering the song so that the user experience is better. And the second method, the onPlayDid change, is a bit easier, I think, because all it cares about is just the isPlaying prop. If the player is playing after the change, resume it, otherwise pause it. And so at this point, we already knew that betting on React Native was a good choice. Like, without even writing any of the native code, we were able to build a cross-platform solution with well-tested logic that was easily extensible. All we done later was just making sure that our unit tests are passing. Like, for example, think about shuffling. We have an array, we have a current track. All we have to do is we just have to reshuffle an array. And the player service will reflect that. It's easy because we know JS, we know these data structures. We used to work with them for a few years. But at first, when I thought how to write shuffling mode natively, I was scared because I didn't even have a clue. So sticking with JS allowed me to build more features easier that are well-tested, maintainable, and I don't have to write them twice, so I don't have to learn Java at the same time in order to target all the devices. All thanks to React and its philosophy that promotes separating, state management and side effects in a very clean way. So at this point, we could have just stopped working on the app and hire some Android developers or iOS developers and just let them implement these 5 methods: start, stop, resume, set track, and play. But hey, wasn't I talking about native modules all the time? As for someone having iOS background, loving native development, that was the great opportunity at work to stress the framework functionality. So I couldn't miss that. So to the native part. Important announcement is that these slides will be iOS first. Sadly, maybe not, maybe it's okay. But 40 minutes is not enough to target all these functionalities. I decided to go with iOS because Android. I guess most of you know the answer why. But if you'll be interested about things like services, activities, applications, or how to do the background playback on Android, I'm happy to show you the app working with source code. Just find me after the talk. So on previous slides, we were calling that mysterious module called Play Manager coming from native modules namespace. So it has to be, I definitely said that word too many times, but it's a native module. So let's go ahead and try scaffolding it. That's it. We just created an empty player manager module. It's not that hard. To be fair, I always find myself copying and pasting that boilerplate. Next step would be to define these 5 methods. We'll just start with an empty body, just to have a code that doesn't break our app during the runtime. So all we have to do is we have to just define these methods and wrap them with the RCT export method macro, which makes these methods callable from the JavaScript. And now, Objective-C is a typed language. So as you can see, a track is, for example, an NS dictionary. It's just an object. that you can access with an array notation. So it's nothing hard. And since we already tested that these methods get called in appropriate places, like we already know that play will be called when we have to play something. All we have to do now is just to focus that play actually plays. And so, important thing to remember here is that if you will be testing a music player application, just remember to choose like a set of songs that you like. I was listening gangsta rap and stuff for like 3 months, and that pretty much changed a lot of things in my life. So I'm not kidding, but if you find yourself like fixing bugs in the evening, you have to be sure that you are working with something that you like. But in order to play the music on iOS, like how we can go about it? Obviously, we have core libraries like Core Audio, and we have third-party libraries that you can find on GitHub. Now, we could use built-in frameworks, but if you have ever used React test utils, I guess you know why we didn't do that. We decided to go with a third-party library that has an enzyme-like syntax, which makes it easier to just write the real logic instead of figuring out how to handle low-level things. And the library we decided to choose was a streaming kit. I was trying to spell the author nickname, but it's kind of weird. Anyway, it has more than 2 years of commit history. It's well tested. And the maintainer is really on the case with the issues. So that was something that we decided to choose. There was also a business motivation behind that, because we wanted to have the media player service implementation living in the open source so that we can focus on building the player, not on handling low-level C code or talking to speakers and stuff. And also, that module is the only one that provides gapless feedback on iOS. And so if you don't know what gapless feedback is that when you have few songs queued up for playback, they are buffered in the background so that when the song finishes, there is no gap between changing the songs. They can even crossfade each other. So it's just a nice experience that you may have noticed in other apps like Spotify. So what we did here to start was something that I'm doing always every time when I'm writing native code. We just checked out the README and copied the examples, hoping they will work, and they did. So first thing we did was we have to initialize something that will be our player. And we do that in the Objective-C land. We do that in the init method, which is something like a constructor on a JS class. And now, if you are wondering, for instance, where a week is, Objective-C has no garbage collector, and it manages memory by counting references to objects. So if there is nothing pointing to an object, it gets swept. So if we would have passed just a strong pointer to this object, we would have created a cyclic reference. So that would result in these objects never cleaned up. And so if you were about to stop playback, your song could be playing because the audio player that's supposed to do this wasn't deallocated. So the weak is just to avoid cyclic references and just make the allocation working. And if you note, there is a set shared audio session category method. Because before we go ahead and implement the play method, we have to tell the iOS what kind of sounds our app will be making. And we do that by specifying an AV audio session category. And now the audio session category helps iOS determine what kind of sound your app is making. Like think of like a turn-by-turn navigation or a Skype. These apps have different use cases, and they use sound or audio feedback for different purposes. And so if you select, for example, the choice here can result in your app being turned off when the phone is turned into the lock screen mode, or for example, no sound when the silence button is turned on iOS. So we checked out the documentation, and we decided to go with the category playback. And now the category playback is the category for playing recorded music or other sounds that are crucial for your app. So for example, no matter if the silent button is turned on or the lock screen is turned on, the music will continue to play. It will even play in the background because iOS won't terminate your app as long as it's streaming something to the speakers with that category. So the implementation was really easy. I mean, if you haven't done any Objective-C yet, my advice would be to just keep checking the documentation. It's very easy. The syntax might be scary a bit at first, but you'll get used to it. And in most cases, implementing things like that is just a matter of copying and pasting several examples. So with that all in mind, we were finally able to go and implement our play method. Since we were passing the entire track object to the native side, we were able to just take the URL off and assign it to a string variable. Later on, we are doing some magic because of types. We are creating some temporary objects like NSURL just to point to the remote resource. In this case, URL is just something that points to MP3 file. And then we just call play data source. And that's all. The music plays. So I feel like that was easy. I mean, there was nothing hard that we couldn't just read. So we were enjoying the app for more or less 4 minutes. And then we have noticed that music finished. But we have like 10 songs to play. So if you are following the slides, you have probably noticed that we've been only focusing on telling the player manager what to do. Stop, start, play. What in an event of an era, or for example, when a music simply ends? There has to be a way to somehow listen to these events and integrate them with our app. And so if you remember from previous slides, there was one line that I've skipped. It's about setting a delegate on the audio player. And now in the iOS world, a delegate object is an object that implements a delegate interface. But the point of that is that if you register a delegate, several methods on this object will be called as your app runs. And so in order to check what methods, you have to check the delegate interface. And in this case, the audio player delegate has these 4 methods. Did start playing, did finish playing, did finish buffering, and unexpected error. So to implement that continuous playback, it turned out really quickly that the event we wanted to use was the did finish playing. Just because it's called each time the song finishes or there is an error. It's kind of, I guess, an implementation mistake, but it's good that we can use 1 method instead of 2. So we don't have to handle unexpected errors in order to skip the track. So since it was the play queue on the JavaScript side that was holding the state, the current song, and other informations, we somehow had to find out the way to pass this information, to communicate this event back to JavaScript so that we can reflect these changes. And it turned out to be really easy with our approach, because essentially what we needed was to just pass this event through the bridge by using event dispatcher. And that's all. Like in this case, we specified a string name of the event, which is player did finish playing track, and body is a track, just for the sake of knowing what track did just finish. However, that wasn't the only part of our task. Like we still had to implement a good interface on JavaScript side in order to handle this. And that interface had to be reusable and extensible because given all these things that we have talked about, like incoming calls, interruptions, we had to build a good interface that will work for many use cases. So we open up the player component again and look back at the component did mount and will unmount methods that we have skipped. Last time we left them empty. This time we'll create an array of subscriptions that will be holding native app event emitter listeners that will be listening to the events that we are sending. And now if you'll take a look at the body of these callbacks, I would say, listeners, you will see that there is no logic. It's just passing the information through props to the outer component, to the parent. And that's mainly implementation detail, stylistic preference, I would say. We just wanted to hide the fact of using native app event emitter inside the player. Because the parent, the play queue, that renders this component, all it cares about is passing track, is playing, and getting meaningful information back. So we don't want to know about low-level things like whether this component is using native app event emitter or whether it's using some any other kind of event passing solution. It just wants to pass a prop and wants to be guaranteed that this will be called when track ends. And so the implementation of OnTrack end as you can see, is simple. Like, it's called, and all we have to do is just set state. In this case, we are just incrementing current track. So there is no crazy logic involved here. But when I thought at first about playing next track on track finish, I was scared because it seemed to me that implementing this on iOS and Android will be rather hard. But it turned out that with this approach, it became very easy because we just had an array and a set of operations, so mutating it wasn't hard. So the essence of what we are really talking about today is that state and events are important. And essentially, that's the summary of all the slides that we've been going through today. It's an overview of an architecture that works really well in the world of React Native when it comes down to writing any kind of native apps. It consists of 3 elements: the state container, the producer, and the native manager. And we have discussed all these 3 elements today. Like state container, that was our play queue. The producer was our player. And the native manager, that was our play manager. And now the state container is something that holds the state, calls set state, and basically tells the rest of the app what's going on and what are the things happening. So the set state call results in a side effect being created by the producer. And the producer just calls native manager imperatively, telling it what to do. When any native changes occur, like track finishes, these changes are abstracted inside these native managers. So because they are small, the process of building them on Android, iOS, Windows is easy. Like with this implementation, bringing the app to Windows platform would be just a matter of learning C#, I guess. Because the rest is simple. 5 methods, body is rather small. Of course, if you keep adding other features, it will grow, but still, I would say it's easier. And so when the event occurs, it's being dispatched back to the producer, abstracted away, and a prop is called so that the state container can handle these changes, and the cycle keeps looping. So essentially, the summary, the final conclusion would be that native modules helps us write better apps. Like, when done the right way, when you know where to draw the line between JavaScript and native code, things like cross-platform code, testability are not even an issue. And if you don't have any clue about writing native code, don't worry, because you are writing a React Native app. It's React, it's JavaScript, so these are your tools. And so with this approach, you can very, very easily put 85% of your entire app purely with JavaScript so that writing native code shouldn't be that hard. So next time you will be about to write any app like that, choose React Native, because with this, you can pretty much bring any native experience to your users, no matter your background. Thank you. Okay, so the question for those who haven't heard was, like the WhatsApp, for example, pulls the messages in the background in order to provide you a better experience when you open the app. And the question was whether this can be done with React Native. So the thing is, like, I was talking about background playback here, but it's a bit cheating because background playback doesn't require background service. So that's kind of easy. For a background service, there is some work on web workers being done in the open source. It's been even, I guess, mentioned on the React Native community a few days ago. But what we have had to do in the past was to just write these services natively. So if we are using something like a shared storage, like Realm or something that can be accessed from both JS and native, we are pulling these messages natively with some APIs and just putting them inside. But I'm not really sure if that's possible. I guess it's not, to just run entire React Native as a background service. That probably wouldn't make any sense in terms of memory. But there is some work going on about web workers. So you can try looking for React Native web workers. There should be more details, and maybe it will fit your use case. So a funny thing is that the iOS implementation of this was just a one file. So I thought it's going to be easier to put it on slides. Android is like 40 files, lots of classes, interfaces, listeners. The biggest problem for us on Android was that there is no good third-party library. So we ended up using Media Player Core SDK for that. And so it had a lot of issues. I would say the biggest problem was threading, because callbacks sometimes were called from main threads, sometimes from other threads. So we had lots of threading issues in our managers. And that was the hardest thing. And lots of exceptions, of course, because of memory. But yeah, I mean, it's comparable, I would say. If you have like some Java background, it should be fine. I didn't have any. So it took a bit more time to learn this stuff. But yeah, it's doable. So. Yes, I'll try to somehow publish that on GitHub. If you don't follow me yet, or if you would like to follow me on Twitter, you can do that. If I'll have something, I'll post it. The main problem is, the legacy issues of kind of open sourcing the client code, but we are working on that. If you'd like to see that in production, I can show you after, like, during the break. Especially the Android part might be the most interesting. So just find me out and we'll figure it out.
I thought iOS is freezing application in background mode, but you tell me we can manage from JS these tracks. Can we manage it dynamically? I mean, not before freezing, not before going to background, but in this moment, when changing the tracks, try to choose these tracks dynamically.
What do you mean by dynamically? Like randomly?
Randomly, but in JS logic. I mean, logic of dynamically choosing, we can keep in JS.
Yes, yes. So that's how it works.
JS in background running.
Yes. Okay, I get it. So the thing is, as I said. Okay. So the question was, I think, was how the JS code is still able to handle events and change tracks even when it's in the background mode. Great. So that's actually why I love iOS so much. I mean, I have heard so many times that it doesn't have background mode and stuff. But the good thing is, if you register the category Playback, your app is not terminated. So that it still works. It still fully works as a background application. I mean, React Native is clever enough to not re-render your app. So some of the things are stopped, but the events, bridge, and set state is working normally. So if you put your app in background, nothing changes. You can just handle an event. For example, if you are in a car, you can still use the controls, handle the event, set state, and that cycle is still looping as long as your app is running. To stop it, you will have to force quit it, because otherwise it'll be playing forever. Yeah, that will be, I guess, last one, and yeah. Could you repeat like a bit louder? If you turn off the screen. So the question is, if you turn off the screen, will the will unmount component method be called? No. I mean, the app is still running. Yes, yes. It will not render because think of it as a sleep mode, something like that. The component is still mounted. It's just the render method is not called because you don't see it. But when you turn the screen on again, the life cycle will be running again and again. The will unmount will be called when you actually remove the component from the body. So in this case, quitting the app. Okay. Thank you very much again. Enjoy the conference.